It's recently made news in Fort Myers, Florida, and on Venice Beach in California. In fact, it's made news 16 times this year, and not good news. I'm talking about fatalities caused by lightning. Fortunately, there haven't been any in Pennsylvania this year, though we do rank in the top 10 states for lightning fatalities over the last decade. Having a sense for the average distribution of lightning can be valuable both for safety and economic reasons. Lightning detection networks have been around since the mid-1980s, mostly run by private companies, so the data is proprietary. But you can find some low-resolution lightning climatologies on the web. Here's one based on data from 1997 to 2010. Not surprisingly, the highest values are in Florida and along the Gulf Coast, the reds and oranges here, and those higher values extend northward into the Mississippi River Valley. If we close in on Pennsylvania, you see the highest values in the southwestern part of the state, with a large general minimum in the central and northern part of Pennsylvania. Now this summer I've been working with a student from Wofford University, Justin Whitaker, to create a high-resolution lightning climatology for Pennsylvania. He used 5 years of data, 2009 to 2013, from the United States Precision Lightning Network, run by WxYz Corporation, which can pinpoint lightning strikes to within a few hundred meters. And here's the result. Officially, this is called stroke density. The unit is strikes per year per square kilometer. Now, a square kilometer is about 250 acres, roughly the size of 200 football fields. The highest values here are in the tan color, between 8 and 12, mainly in southwestern Pennsylvania. So in these areas, for that 5-year period, they got between 8 and 12 lightning strikes per 250 acres of land. For perspective, the most lightning-prone areas of Florida would have 3 to 4 times that. Now, this maximum is clearly connected to higher thunderstorm activity in the Ohio Valley. Now, as you move east into the higher elevations, stroke density does fall off, though even in some counties with fairly high elevations, such as Cambria and Indiana, you can see a little bit of yellow, which is 6 to 8 strikes per square kilometer per year. Stroke density reaches a minimum on the eastern side of the Appalachians, where the terrain is generally sloping down, but then picks up a bit in the lower elevations southeast of the mountains, which have better access to warmer and moister air. York and Dauphin counties, for example. The lowest stroke densities for this 5-year period were in the northeast, the blue shading, to some extent correlated with the highest elevations of the Poconos. Now here's how those strikes break down by month. July has the most, by far, almost 30% of the total. June is a bit ahead of August for second place, and May is a bit ahead of September, showing that late spring and early summer tend to have more thunderstorms than late summer and early autumn. Though these results are based on only 5 years of data, they're a great starting point for high-resolution studies of lightning in and around Pennsylvania. And I will share more of Justin's results with you at a later time. Paul Knight is back next with the extended forecast.